Hey, it's Superwoman. Actually, it's Miss Hodges, and this is the second in the series of the Matter videos. And much like Superwoman and Superman here, I am made of elements. You'll notice in the picture of Superman, you can see teeny pictures. These are minute pictures that make up the big picture of Superman. Much like other elements, all elements are made of tiny little particles called atoms. The atom is the smallest particle of an element that has all the same properties of that element. They are way too small to be seen by a microscope. The word atom is derived from the Greek word that means cannot be divided. They were first discovered by a Greek philosopher named Democritus over 2,000 years ago. He believed that the universe was full of empty space and tiny particles that cannot be broken into smaller particles. These particles were atoms. Most ancient scientists dismissed Democritus' theory. But John Dalton, a British scientist in the late 1800s, also believed they were atoms. He stated that all of the atoms of a particular element are identical, but different from the atoms of all the other elements. Atoms were once thought to be the building block of matter. In 1911, scientist Ernest Rutherford provided evidence that atoms are really made of positively charged nucleus orbited by a negatively charged electron. The nucleus is in the center of the atom, and there you see the proton, which is the positive charge, and then the electron that orbits, much like planets orbit the sun, orbits the nucleus of that atom. In 1932, Rutherford's student discovered that not only was there a proton in the nucleus, there was also a neutron, the negatively charged particle. Here are all the parts of the atom. A nucleus, which is in the center, has positive charges and neutral charges, and then a negatively charged electron orbits around the nucleus. All atoms are made of protons, neutrons, and electrons. So with over 100 different elements, they must be identified by their atomic number. The atomic number is the number of protons in the atom's nucleus. Hydrogen has one proton, so its atomic number is 1. Gold has 79 protons, so its nucleus, so its atomic number is 79. We also use the atomic mass number to identify atoms, and that is the total number of protons and neutrons added together in the nucleus. This link takes you to an interactive periodic table that has all the elements found in the world. You scroll over the different elements and it pulls up and will show you that particular element. For example, manganese. It has a atomic number of 25 and its atomic mass is 54.93. So the atomic number 25, it has 25 protons in its nucleus. And it has, when you add the neutrons and the protons together, you get the atomic mass of 54. Here's hydrogen. Atomic number of 1 and atomic mass of 1. Gold. Has an atomic number of 79, and when you add the protons and neutrons together, it has an atomic mass of 196.96. Go to this link and experiment with the metals, metalloids, and nonmetals of the periodic table. All are elements found in the natural world.